Square root of 4 is 2. Square root of 9 is 3. What would be the next one? Square root of 16 is 4. You could do the numbers in between, but they wouldn't be very nice. You'll also notice that I didn't put negatives here. Desmos will automatically default to negative 2 to 2. We will not, because we know that you can't take square roots of negative numbers. And so we're going to graph what fits. That would be 0, 0, 1, 1, 4, 2, 9, 3. That's 10. Sorry. 9, 3. There you go. Okay, this is a square root function. You might remember from the fall we looked at the graphs a little bit and just talked about the names of the parent functions and the equations. My domain goes from left to right. So domain, it goes from 0 to infinity. And it's the x values, so I'd say the x values are greater than or equal to infinity because you have a point plotted. It's been a while. Okay, range is the y values, remember? So we go low to high. So it's going from, again, 0 to infinity. So your y values on a square root function, that's what this is y is greater than or equal to 0. So we are graphing this one up here. Okay. You notice it's only positive again because you can't take the square root of negative numbers. You get I. We good here? Sorry. So this guy we're going to switch to be like 2, 4, 6, 8. And we're going to do the same thing on the y-axis as well. 2, 4, 6, 8. Hindsight's 20/20. So just fix that across the board, right? Okay, and we're going to graph cubes this time. So I would only want to choose perfect cubes. I mean, could you do other numbers in between? Yeah. But it's not going to work out very nice. I don't really care for the decimals. In the middle, you're going to have 0, 0. The cube root of 1 is 1. What's the next perfect cube? I don't know if your perfect chart is out or not. 8. What's the cube root of 8? 2. You can also have the negatives, though, because you can do the odd root of a negative. Cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. Yeah. So when we go to graph this guy, it's going to be, because I changed the scale, it's going to be like this. That 1, 1 is kind of like in the middle of a square. Sorry, I didn't give you a big enough graph. And then 8, 2, and then negative 8 and negative 2. So it's like this squiggly situation. It's the inverse of a cubic function, so it's like sideways cubic. This is a cube root. Make sure you have the points plotted and not just a random like squiggle. Here's what's nice about the domain and range, though. It's going from forever from the left and forever to the right. What would you say for the domain? Do you remember what you say? This is all real numbers. You can write out on words or use that like double-lined R. The range is also going to be all real numbers because it keeps going very slowly, but it does keep going up, 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 up forever. And so they're both all real numbers. For the cube root function, we are graphing this one, okay? So there's our two parent functions for the day. This is a vanilla ice cream. We're doing transformations with it. We have done transformations before. It should seem familiar, okay? If you have colors, we're about to use them. Flip the next page. We are dealing with the square root function first. So up at the top left here, if you could, 500%, look at that. Okay, you're going to take these points, I'll do it in purple, right? 0, 0, 1, 1, 4, 2, and it looks like you can't fit 9, 3, so that's fine. Those are the points that you need. You can see that there's, I don't know how many graphs on this page, 6. So I need you to take that graph and copy it because I didn't have the hindsight to do that. So can you please draw the parent function, all of it? You're going to do 0, 0, 1, 1, 4, 2 on all 6 of these other graphs on the page and draw the little tail cube root function, okay? So right now you're going to go at all 6 and draw them in because then we're going to do the transformations with that. I don't know if I can get all of them. There we go. So I should see you being like, okay, I'm going to draw on this graph with 0, 0, 1, 1, 4, 2. Tail. Rinse and repeat. Okay. 0, 0, 1, 1, 4, 2. Little tail guy. Do you understand what I'm asking you to do? Okay, do all 6, and then we'll talk about the transformations. Anything inside the function, so in this case, inside the root, is going to do opposite of what you think. First thing we're going to see today is the vertical up-down. So these ones will behave as you expect. This one, I'll circle it for you. This is it says square root of x plus 4, so it's going to go up 4. This is the k. The k behaves as you would expect, right? So I'm going to take these little points, and you literally just count squares. We have done this before. 1, 2, 3, 4. I'm going to go pretty fast. I hope that you have your colors ready or your pencil ready. I don't know how you're going to note it if you don't have colors, but you could just, I guess, make sure it's separate, right? There you go. That's the first one. Up 4. What about that minus 3 at the end? What's that going to do? That's the next function. It's going to take it down 3. And these are called translations when it shifts left, right, up, or down. So this guy goes boop, 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 down 3. And you can just count your merry way. You are also welcome to use Desmos anytime you want. I would say these shifts are like pretty easy. Come on. As long as you have the parent function, you can shift it around. Okay, we're going to move on to horizontal. This is where you have liars, okay? So inside's a liar. Inside this first one, I see x plus 6. I would think it would go right, but actually it goes left 6. Weird. So taking that parent function and shifting it left 6, your endpoint originally was at 0, 0. Now it's at negative 6, 0. There he is. If you were to type it into Desmos, that's exactly what you would see. What about the next one? X minus 1 takes it? Right 1. Yeah. Inside's a liar. So now my endpoint is going to be at 1, 0. It's going to shift right. So taking from the parent function, right 1. There it is. Kind of like, it's very close to the other one. Sorry about that. Okay, this is the most difficult out of the bunch. Is your stretch and shrink or your stretch and compressions. I'm just going to quickly jot down what these points that we had are, right? So we have x, y. We've been using the whole time for square roots. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Do you remember what you multiply by when you have a vertical stretch or shrink? You multiply the y values. This is a confusing one. Also, just a reminder that it's a vertical stretch if the a value is greater than 1. So in this case, I have a stretch because it's 4, which is bigger than 1. So I'm going to take these y values here, and I'm going to multiply my y values by 4. Yeah. So make a note of that because this is the one that's difficult. Multiply y by 4. If you haven't typed anything into Desmos yet, this would be a good one to start with because these stretches are like, it's just kind of confusing. Okay, let's be honest about it. And you don't have to do it by yourself. You can graph it. There's no secrets. So 0, 1, 4, and I multiply my y values by 4, they would become 0, 4. 2 times 4 is 8. If you haven't typed it in, I would. 0, 0, 1, 4. The stretches, remember, get like kind of taller or stretched away from the axis. Stamp. So that first point doesn't move, didn't go left or right, but you can see that it's literally stretched out, like further away. Do you remember what the compressions do? Shrink, same kind of deal, right? Except that it's less than 1 or between 0 and 1. So in this case, you are dealing with a 1/2 things, meaning that the y values get half the size. So you multiply y by 1/2. Multiply y by 1/2. Sorry, it's kind of down here below that. So again, if you wanted to jot down your table, you could. X, y, 0, 1, 4, 0, 1, 2. So then your new values would become, I'm going to highlight this, changing those, and sorry, going to multiply them by 1/2. It would be Wow, that's too close to the logo. 0, what would the next one be? Half of 1 is 0.5, and half of 2 is 1. That's a 1 right there, sorry. There we go. You just have to understand that your y value is getting closer to your x-axis, so now it's going to be like here. You can see it's been like compressed. Those are the most annoying ones. Use a graph. It's fine. There's also a table feature on Desmos. Do you remember where that is? Click settings table. I'll show you more of that in a second before I let you finish the rest. And then the last thing is the reflections across the x and y axis. Remember, if the negative's on the outside, it's reflecting vertically. So that would be reflecting over the x-axis. So it bops like down below. There he is. If the negative's inside, it reflects across the y-axis horizontally, right? So it goes like this. Thank you, Jancy. Okay, 0, 0, and then it's flipping the other direction. This is like speed round review of transformations, I know.